example 3, we have a crate here, and the weight of that crate is 50 pounds. So you need to remember this here. They give us the weight, not the mass. So in order to use the mass, you need to divide by the acceleration. And when you are dealing with the US customary, you need to divide by 32.2 foot per second squared. So take care of that point. So here we have a crate with a weight which is 50 pounds. And it's acting upon a force having a variable magnitude. So here we have a force acting on that crate, and that force, it depends on the time. So the force here, P equal 20 T. T is the time in seconds. So this time, the value of P is variables. It depends on the time. And we need to determine the crate's velocity 2 seconds after P has been applied. So we need to know the velocity after we were going to apply that force after 2 seconds. So we have that box, and we need to know the final velocity after we apply a force equal 20t during interval time 2 seconds. We have initial velocity for the box. So the box initially was moving with 3 foot per second down the plane. So the direction of the velocity is just like that. And also, they give us the coefficient of kinetic friction between the crate and the plane, which means that this time we are going to have frictional forces. So this example, we have a variable magnitude of P. It depends on the time. We have frictional forces, and we have inclined plane. So now we need to determine the final velocity after we apply that force for 2 seconds. Since we have forces, we have velocities, and we have time, it's best to use the principle of linear impulse and momentum. So in order to apply the principle of impulse and momentum, we need to take care of the force. Since the force here is variable, depends on the time, we need to be attention that when determining the impulse, because of that force, we need to integrate. So we are going to integrate from 0 to 2 seconds dt in order to determine the impulse from that force. So don't forget about that. The force here is not constant. Then the first step need to be done. We need to establish the XYZ coordinates. So since the problem is 2D, we need to put X and Y. Here we have the plane is inclined. That means it's better to put the XY aligned to that plane. And here is the direction of the velocity. So it's better to be the X axis, the positive is going to be in this direction, because this direction is the direction of the motion. So I'm going to put X and Y aligned with the that plane here, and the positive X is going to be in the same direction of the velocity, because the velocity it's directed in that direction. So when I put the XY like that, my work is going to be easy. I'm not going to resolve a lot of forces. Then I need to draw the particles free diagram. It's easy, we'll learn how to do that. So here we have the weight which acting down. We have normal force perpendicular to the plane, and also we have frictional forces, and we have the applied force. So we have the applied force here, and we have the normal force acting perpendicular to that plane, and we have the frictional force tangent to that plane, and we have the weight of the box which is going to act down. So like you can see here, when we set up the coordinates, all the forces is going to be either into X or into Y, except the weight. So I need to decompose only the weight into X and into Y. And also the positive is going to be in this direction, the positive X, and the positive Y is going to be in that direction. Now we are going to establish the direction of the particles' initial and final velocities. We need to put the direction of the initial velocity and the direction of the final velocity. And as a result, or consequently, we need to draw the impulse and the momentum diagram for the particle. So here we have the direction of the V1 in this direction. We are going to have the mass times the velocity. The mass here in the question, they give us the weight. So I need to divide it by the gravity. And in US customary, the gravity is 32.2 foot per second squared. So this quantity here represents the mass. And it should be multiplied by V1. This represents the initial momentum diagram. We show the direction, and here we have the quantity. Then we need to put the free body diagram, the impulse diagram. So the impulse diagram is a free body diagram during the time interval. So we already draw the free body diagram. Then we need to add the time interval. Then we are going to have the final momentum diagram. Here we have the direction of the final momentum diagram is the same direction of the velocity. And here we have the mass, because the momentum is the mass times the velocity. Now I need to apply the principle of work. I need to apply the principle of impulse and momentum. In order to do that, I am going to use the scalar components for that equation. So in order to use the principle of linear impulse and momentum, we are going to use the component into x. So now x, it's like that here. So in order to use the principle of linear impulse and momentum into x, I need to decompose all the forces into x and into y. All the forces directed either into x or into y, except the weight. So I need to decompose the weight into x and into y. So I'm going to have sine 50 sine 30 and 50 cosine 30. Now I'm ready in order to use the scalar form into x. So I'm going to use the scalar form of the principle of linear impulse and momentum into x direction. And the positive x is going to be directed here. So now the value of m is here. The value of initial velocity is here. Then I need to know the summation of the integration of fx dt. In x, I have the applied force. Depends on the time, so I need to integrate this. Also, I'm going to have 50 sine 30. Since this value here is constant, I'm going to directly multiply it by the time interval. Also, I have the friction here. Also, since the friction is constant, I need to multiply it directly by the time interval. So I have this force, need to be integrated. This one here, directly I'm going to multiply it by the time interval. The same thing here. This one is going to be positive, this one is going to be positive, and this one is going to be negative. And regarding the final momentum, I know the value of the mass. I don't know the value of V2, which I need to evaluate. So now, instead of m, I know the initial velocity in this direction. Regarding this part, I'm going to integrate the bt from 0 to 2 seconds. And regarding the friction, since it's constant, I'm going to multiply it by the time duration, and the force is going to be negative since it's opposite to the positive x. And I'm going to put the 50 sine 30 in this direction, and it's going to be positive, and I'm going to multiply it by the time interval, which is 2 seconds. Then I'm going to put the mass, and I don't know the value of V2. So in this formula here, I don't know the value of NC, and I don't know the value of V2. I'm going to simplify that equation. This part is going to be 4.658. The integration here is going to be 40. Here I'm going to have 0.6 NC. This one will give us 50, and this one is going to be 1.55 V2. I don't know the value of V2 and I don't know the value of NC. So I need to apply the principle of linear impulse and momentum again, but this time we are going to use the scalar form in y direction in order to know the value of NC, because the equation here cannot be solved. So I'm going to apply the principle of linear impulse and momentum in the scalar form in y-axis in order to determine the value of NC. So I'm going to apply the principle again, but this time I'm going to use the scalar form in y-axis. So the positive is going to be here. Here is our direction. Here I don't have velocity, so this part is going to be 0. Also here I don't have the velocity, so this part is going to be 0. Regarding the forces, I have the 50 cosine 30, and I have NC. And this one is 0, and this one is 0, so I have NC positive is going to be multiplied by the time interval, and 50 cosine 30 is going to be negative, and also is going to be multiplied by the time interval. So this one is going to go with that one, and then NC is going to be 50 cosine 30, which is 43.3 pounds. So now we determine the value of NC. We are going to get back here to that equation. We are going to substitute the value of NC in order to get the value of the velocity. So the velocity V2 came out to be 42.2 foot per second. So here I use the principle of linear impulse and momentum into X and into Y. So now I'm done with that example. If you have any question regarding this example, please ask me. So also, before we finish, we need to know that this example also it could be solved by the equation of motion. So that example, it could be solved by the equation of motion. We need to draw the free body diagram, which is here. Then we are going to say that the forces in X axis here is going to be the MA, which is the initial force. So here I'm going to get all the forces in X axis. I'm going to have 20T. I'm going to have the frictional force, and I'm going to have the component of the weight in this direction, which is 50 sine 30. If I'm going to apply the forces in y-axis, the value of NC is going to be 50 cosine 30. So I can know the value of NC. I'm going to put it here. So if I'm trying to solve this problem here, I have only A. The acceleration is going to be as a function of the time, t. So now I determine the acceleration, and the acceleration came out to be as a function of the time. Why? Because the applied force also is a function of the time. So now I need to know the velocity. In order to know the velocity, I need to use the kinematics relations. So in the kinematics relation, I know that the acceleration is dv over dt, which means that dv is going to be a dt. I have the a. I need to integrate with respect to t. So I'm going to integrate with respect to t from 0 to 2, because from 0 to 2 we have the time interval. If I'm going to do that, the velocity is going to come out to be 42.2 foot per second. And I need to take care of the integration limits for the velocity, because the initial velocity is 3 foot per second. When the time is 0, the velocity is 3 foot per second. So you need to take care of that. So that problem, it could be solved using the equation of motion, but I need to use the equation of motion, and also I need to use the kinematics. But if I'm going to use the principle of impulse and momentum, I'm going to use only one equation, either into X or into Y, and sometimes both of them. So by comparison, if I'm going to compare between this method and that method, application of the principle of impulse and momentum eliminates the need for using kinematics. So I don't need to use this here. And thereby yields an easier method for solution. So you could use the equation of motion, but we need to use the kinematics. But if you are going to use the principle of impulse and momentum, you are going to have only one solution for that. So here I'm going to ask you a couple of questions to check your understanding. The linear impulse and momentum equation, it's obtained by integrating something with respect to time. Number A, friction force. B, equation of motion, kinetic energy, or potential energy. So in order to get this, it's which one is it? Which one is it?
Equation of motion, Doctor.
Yes, you are going to integrate the equation of motion with respect to time. So the right answer is B. Which parameter is not involved in linear impulse and momentum equation? So we have a variable which is not included in the linear impulse and momentum.
Displacement, Doctor.
The displacement. We don't have the displacement.
Yes.
The displacement, it's included in which equation?
Motion. Equation of motion.
In motion, no.
Potential energy, Doctor, I think.
Kinematic.
Principle of work and energy. We have the displacement in order to determine the work, right? To determine the work, I need to know the displacement. So if I'm going to have a problem that involves displacement, force, and acceleration, it's better to use the principle of work and energy. If I have a problem that involves the velocity, force, and the time, it's better to use the principle of impulse and momentum. So which equation is going to involve the acceleration and the forces?
Equation of motion.
Equation of motion. It's very good. So now here, we need to determine the impulse due to a force. But this time, they represent the force graphically. Here I have the time, and here I have the force. When the time is 0, the force is 0. When the time is 1, the force is 10. When the time is 2, the force is 0. But here the graph represents the force. So in this case, we need to determine the impulse because of that force. Remember, I said we have 3 cases. Either by the graph, or the force is going to be as a function of the time. In this case, I need to integrate. Or if the force is constant, I need to multiply by the time interval. So in this case, what should I do? In this case, what should I do? I have the relation between the force and the time, but this time it has been represented graphically. We said that in order to know the impulse, I need to determine the area under the curve.
Yeah.
Area under the curve here is going to represent the impulse. So which one is it?
10.
A or B or C?
It's B.
It's B. So B is the right answer for that. So I'm going to stop here.